again, take a word problem, formulate it as an LP, but then focus on how to solve it using Excel Solver. So for this problem, we're going to model the supermarket sweep game show. It might be a little bit before your time, but you can Google or look up YouTube videos. But the idea of it is that at the end of the game show, you have a grocery cart and you can run frantic throughout the grocery store and fill it with whatever from the aisles that you want. But the objective is to have the highest price cart at the end of the time or you filling your grocery cart. And so we're going to take this and model it using a linear program. And so for this, we have a couple different things. We are going to set the capacity of your cart to be at most 200 units. And then keeping with the show's goal, you want to win the game show. You want to therefore have the highest total cost cart by filling it as much as possible. And we make a couple assumptions here. First, that you can take partial items, and second, that there's no time limit. So you're an amazing shopping cart runner between the aisles, you know where all the good items are, and you can fill up your cart in the time that they would have allowed in the game show. So those are our two assumptions. Here I have a list in our grocery store. It's a small grocery store. We only have 20 items, and we have their associated cost and size as well as a category. We're not allowed to take more than 3 of any item or each item, and further, we must take at least 1 from each category, so we need a balanced cart here. And we ask, what items will you put into your cart? And so first we have to ask ourselves, what are our decision variables and what's our objective function? So here, this last question here kind of gets to what our decision variable is. It's how much we're going to put for each item. So I have this written up. Let me just make this black. So here, our decision variables, we're going to say xi, and I'll get to what the I is the amount of product I that we put into the shopping cart. So because we have 20 items, before we would have listed x1, x2, x3. Here I'm just using I to essentially equal the item number. So if I was apples, then in xi equals 2, we put 2 units of apples in the cart. And so we're going to label it as x1 through 20. So start at the top of the list is x1, x2, all the way down to pasta is x20, because there's 20 items. So that's our decision variables. Now we need an objective function. And so for the objective function, I have most of this all typed out just to make it quicker, but we want to have the highest price cart. And if we go back to this, each of our item has an associated cost. And so if we thought imaginary that our xi variables are right here in this column, we would have, let's say I have 2 turkeys. The cost then of those turkeys is its cost times the amount of turkeys in it. And so we want the sum over all items, their costs times the amount of that item we have. And so taking that, I'm going to do maximize. I want the highest price cart, 15 times x1 and 25 times x2, which is just going back here. This column times the amount of each item. So now we have to look at what kind of constraints do we have. And so the first one that we see here is let the capacity of your cart be at most 200 units. Here we have an associated size with each item. And so sort of like we did with the cost, we're going to do with the size. So if I had 2 turkeys, that would take up 20 units. And we want to limit the total size of all of your items that you pick by 200. So with this, I just take, so here's our first constraint, and it's just taking the size times your decision variable, the amount of that item, over all of 20 items, and limiting by 200 the capacity of our cart. So that's our first constraint. Our second constraint, here going through this, we want the highest cost. We already have that in the objective function. We assume you can take partial items, which will allow by having xi be a continuous variable rather than integer. No time limit, so there's nothing we need to model with that. Here just gives us our 20 items. Here's the next constraint. You're not allowed to take more than 3 of any or each item. So I can't have more than 3 turkeys, 3 cereal boxes, and so on and so forth. So to do that, I just write it like this. I limit each variable to the amount I take and limit it by 3. Here I use shorthand, just saying ... to be x3 through x19, and I just list the last of the range. This is one way to do shorthand if you have a lot of variables, which we have enough in this example, which again motivates why we're going to use solver. So then lastly here, further, we must get at least 1 item from each category. So we have to have the sum of our items in the meat and seafood category be at least 1. And so here, if I just look at meat and seafood, this is x1, x2, x3, that has to be greater or equal to 1. And then you would do it the same for each of the other categories. So I have this written out for our different categories. This was the meat and seafood. Then I think it was produce, baking, health. So this is produce, baking, health, and then the other foods. So it's just essentially summing up the amount in that category and saying it has to be greater or equal to 1 so that I have a balanced cart. And that makes up our last constraint that's listed. Again, you have to have non-negativity, so we cannot have negative items in our cart. And so I just here, again, use shorthand, the ... that x1, x2 through x20 all have to be greater or equal to 0. And so that makes our full linear program. Now we're going to take this and code it up in Excel and solve it. So before, when we solve things, we use the graphical method, and that was great with 2 variables. Maybe you guys are sophisticated graphers out here, but I am not and would have struggle graphing 20 variables. So to do this, I have an Excel spreadsheet with just the data already in it. And so now we need to have a spot for the decision variables. So I'm just going to put this here, and I'm going to call it xi. I'm just going to write it so I remember it's the amount of each item in the cart that we put in the cart. And so that is going to correspond to this column here. So I want this amount of, actually I just want to underline, so xi here, if it was 2, it's saying I would have 2 turkeys or 3 bags of coffee. And so those are my decision variables. And now I need an objective function. And so thinking back, looking here, my objective function was just the cost times the variables. And it's a maximization. I have to remember that. And so Professor Sharkey showed in class the idea of the sum product. So I'm going to take this cost, this column here, and multiply it times these variables. So however much is going to be in there, and that is going to be my objective function. That's going to be the total cost of my cart. And the same thing accomplishes by taking this times this plus this times this cell. And so sum product is just easier shorthand for it. So I'm going to color code this just so I know where to look when I'm trying to find things. So there's my objective function. Now I have a set of 3 constraint sets. So this constraint here was saying I'm limiting the capacity by 200. So here I have to take my size times my set of variables. Again, I'm going to do sum product and limit it by 200. So here I'm just going to call this constraint 1. And in this cell here, I'm going to do sum product of the size column and the variable column. So they have to be exactly the same so that it knows which element of essentially the array to multiply times. So there's the total size, and I'm going to limit it by 200. You can just write 200 when we get to it in the in Excel solver, but I explicitly write it here so that it's easier to just change this cell rather than the constraint in Excel solver. So now we're going to go to constraint, I'm going to call it constraint set 2. And this constraint is saying each of my variables has to be less than or equal to 3. And so when I go into solver, I'm just going to select this set of variables, and then I'm going to limit it by 3. So I'm just going to type in 3 here. So if I ever want to change it in the future, it's just going to be easy to change this to a 5 or whatever value I want. And so now my last constraint, set 3, was essentially saying I have to have something from each category. And so we could write everything out, and I could sum, like I did in the LP here, sum x1, x2, x3, and say it has to be greater or equal to 1. So this plus this plus this. But I am going to do it slightly different that will accomplish the same thing. So I'm going to paste this here as values and remove the duplicate. So I just have each of my individual categories. And there's a sum if function that takes in 3 arguments. So this is teaching you other Excel functions in the meantime. So sum if, I want to know, hey, what of these category, what in this range, which I'm going to lock right now, equals this, meat and seafood. So it will go through this and it will find, oh, that does equal meat and seafood. And then this last range that I'm going to input. So the first range, then you have criteria, what will it equal, and then sum range. So if this value equals meat and seafood, I want it to sum the corresponding value, so essentially this cell, in this second F range, column F. And again, I'm going to lock it because I'm going to carry this down, and it's going to do the same thing for produce. So it's going to essentially say, okay, what of these equals produce? It will find these 3 and then sum those. And so I'm just going to carry this down for all 5 of my categories, and then I'm going to say they all have to be greater or equal to 1. And so there's my 3 constraint sets, and then I will put in non-negativity as well. So let me just go ahead, color code this. And so now we're ready to actually put this into solver. So in my version of Excel, I'd go to Tools, Solver. And first you have to set the objective function. So we already have it stored right here as the cost. I want to maximize that value. Now I have to put in my decision variables, the by changing cells. So I want to change these variables right here, the amount in each item in the cart. And now I have 3 set of constraints. And so I'm going to add them one by one. So first constraint was that this size, so we already set this up as the amount that my items are taking, and this has to be less than or equal to, I'm going to put in here 200. I didn't click over that, and then this here is 200. So like I said before, you could just type in 200 right here. But let's say they downsize the size of their carts. You would have to go into Excel Solver and change your constraint and write 150 here instead. Or you could just change this cell right there and resolve. So I'm going to add that constraint. Now I have my second constraint set, which says that each variable, so each of these, amount in each cart, or amount of each item in the cart, has to be less than or equal to, again here, 3. I'm going to add that. And then last, my constraint, it says that I must take something, at least 1 from each category. So here I use my sum if formula. I'm going to say each of these has to be greater or equal to 1. So that, I'm going to change this to greater or equal to, and then say these all have to be greater or equal to 1. I'm going to add that. And then depending on the version of Excel, you might need to just add non-negativity just to be careful. So here I'm just saying each of my variables has to be greater or equal to 0. I'm going to add that. I don't have any more constraints to add. So just to review, here was my objective function. I'm changing these decision variables. I have a constraint here, the first constraint, that says the size has to be less than or equal to 200. My second constraint says, so this is C34. So this constraint actually is this one saying each of your categories has to have at least one item. And then this is saying that you cannot have more than 3. And then this is your non-negativity. I'm going to use simplex to solve. And then I'm going to just click solve and hope it does its correct magic. So it might take a little bit of time depending on what else you're running. And so it worked. So it says solver found a solution. All constraints and optimality conditions are satisfied. That's what you want to see. And you can use different reports, but we're not going to, and we're just going to accept this solution as is. And click OK. And it's good to then check to make sure everything makes sense. So here, let me look at my answer. None of them are greater than 3. Here, the size of my cart is 200. It's at its maximum. Here, I have at least one item from each category. So it looks like all of my constraints are satisfied and I do have a feasible solution. And so here, the winning cart has a cost of $337. So that concludes our second video tutorial. Again, feedback is appreciated. And if you have any problems, please feel free to request anything on the website. Thanks.